if it's this blue thing, we put the blue thing right into there. See, right into there. And now we need to go ahead and substitute into the original function. Well, the original function, of course, as you know, it is, we already know what that is. It's that one, 2x plus 1 over x minus 3. And so everywhere, we see an x in the original function, well, we have to put, the one plus 3x divided by x minus 2. Just the way that it works. So now so it's equal to 2 times x, which is this whole blue thing. So 1 plus 3x over x minus 2 plus 1 over, and then x, which is this whole thing again, 1 plus 3x over x minus 2 minus 3. So it's this. Now we want to see that comes out to be x, but that's getting a common denominator. We get 2 times 1 plus x. Now it's just algebra plus x minus 2 over x minus 2 divided by, same thing on the bottom, we just get a common denominator. And we get 1 plus 3x minus 3 times x minus 2. Well, now at this point, these cancel away, the x minus 2's, and we just need to simplify. But the key step, was, of course, it was doing this, making that substitution into the original function f. Everywhere we saw the blue thing, we had to put it over here, where x was, for the original function. That's so. Anyway, we've been through that already. But 2 plus 6x plus x minus 2, and then we get, the 3x's cancel away, and we're left with 1 plus 6, and that becomes, the 2's cancel away here, we're left with 7x over 7. Well, that is x. So that is correct. It does work out to be x for that, for f of f inverse of x, but for some reason when we did it, for f inverse of f of x, it didn't come out to be x, and I'm thinking it had to have been an algebra, error, somewhere, in this, process. Unfortunately, those things can creep in from time to time, and they can really be, a headache to try and, solve it. But we're going to find out, where I made my mistake, because it's important. But now I'm pretty sure that we did everything right. We just made a little simple algebra error in here. And so let's look at it more closely. The substitution, I think, was correct. And, but over here, they canceled out. X minus 3 plus 3, okay, that's okay. And 2x plus 1 minus 2 times that looks okay. X minus 3 plus 6x plus 3 divided by 4. X plus 1 minus 2 times x minus 3. And so that should that be a 2's cancel, 1 plus 6. That should be a 7 on the bottom there, actually. See, 7. And actually, the negative 3 and 3, that's a 0, that's not a 6. So I just made a silly algebra error. So that's equal to 7x over 7, which is equal to x. So, I mean, really, it was okay. I just made a stupid little algebra error on the verification. But, there's nothing wrong with what we originally did, over here. I mean, that was okay. That stuff, that was solid. There's no question about, what we did here. We went through that. We got the inverse function. And the graph, I guess, that the graph, I didn't really draw a very pretty graph, but, let's go take this is not a graphing problem, but I really don't see how someone could really understand, what's going on without, knowing how to graph it somewhat. Just a basic graph helps in some cases. You can solve the problem without graphing it, but, I just wanted to draw a little bit better of a graph of what this function f actually looks like. And so I'm going to draw the function, in white, and I'll draw f inverse in a different color. And so, you can see how they both look together. Well, at 1, 2, 3, at x equals 3, there is this, vertical asymptote for the function f. And also, at x equals 1, 2, there's also, the horizontal, asymptote. And as we saw from our analysis, it does this on the right side, and then it does this type of thing on the left side. That's what it looks to me like, based on a very cursory analysis. But this is a pretty simple function, and that is, y equals f of x. And now, but the inverse function, is different. It is, y equals f inverse of x. Well, where its domain is not defined at x equals 2, so, it's a little bit, so we have to, write x equals 2 as the vertical asymptote in that case. For f inverse, that is. And looking at it, this y equals 1 plus 3x over x minus 2, that's the f inverse. So it's got a vertical asymptote at 2, and as x goes to infinity, it looks like it has a horizontal asymptote at x equals to 3, which of course is true, because anywhere the original function has a vertical asymptote, it has to have a horizontal asymptote. So here is the point 3 right here, and here's your horizontal asymptote for f inverse, and now we just need to graph f inverse. Well, at x equals 2, if you're to the right of 2, it's going to go to plus infinity, and so it's looking like it's going to it's looking like it's going to be like this, something like that red, right there. And then to the left of 2, it's going to be to the immediate left of 2, it's going to be some very small negative, big negative quantity. So it's going to go up, and it's going to approach, the point 3 from below. Because we're going to be dealing with, so it's going to do this, and is it ever 0? That's the point. Well, it is equal to 0 this, you know. Strange looking thing, you know, it is a strange looking thing. But we're graphing them on the same, you know, axes, you know, and it's supposed to be like a reflection about the line y equals x, something like that, you know. But this is a more complicated thing to see that reflection, I guess. But at any rate, you know, that's the thing. I mean, you know, we worked an algebra problem. This was an algebra problem, you know, taken from an algebra, you know, thing. And like I said, we can look at other, you know, problems, other types of problems, and you know, just try to get you up to speed, you know. So, I mean, where there's word problems, you know, that we can look at, you know, and I'll be happy to, you know, help you with as many problems as we can work, you know. I feel like, you know, it's better to take a lot of time working on, you know, 1 or 2 or 3 problems than it is to, you know, to not help you, you know, enough, you know, with any one problem, and then you don't walk away feeling like we really accomplished anything, you know. So, you know, we're just, you know, need to, you know, try and work together, and you know, I'll come prepared with problems to help you, and you know, come prepared, you know, to ask questions and see problems worked, and you can work along with me. You know, you can tell me what you think we need to do with a certain problem. You can try to work it there, and then if you're having problems, you can say, well, I'm stuck here. What do I need to do then? I'll work it. I'll show you what I would do. You know, so at each step, you know, we can stop at each step and let you try to work it. You know, and if you can, great. Then you did it. You don't need more help with that. We move on to the next problem. You know, because there's always going to be more problems. I'm not the type of math tutor that just, you know, doesn't, you know, do anything and just sits there. You know, I want to be working problems. You know, I want to be working problems that are going to, you know, help you. You know, and you know, I'm a high energy type math tutor. You know, I don't just like to sit there, you know, staring and, you know, waiting for you to do something or ask something. I want to bring something, you know, of value to you, you know, to help you, and you know, have you walking away having learned something and feeling like you benefited somehow. You know, so you know, it's algebra. This is algebra, but you know, it could be in any subject. As I said, it could be, you know, calculus. It could be trig. It could be pre-calculus business math. You know, I'll find the practice exams. I'll find whatever type of, you know, homework, you know, I can, you know, online or wherever. Or you can bring me problems, you know, that you'd like to solve, or I can pull problems out of my books. I have some calculus and, you know, I have some math books, you know, that have problems in them and things. I can always pull out example problems and things for us to work on, you know. So, you know, and just trying to make it good for you, you know, and I hope that you'll let me do that. So thanks a lot for watching. This is Jimmy signing off.